for concentration methods. So you should have a calculator out and you should have a periodic table out. What is the percent by mass of 30 grams of HNO3 and 200 grams of water? That's going to be 30 part divided by the total. Part divided by the total, and 3 divided by 23 is 0.1304. So that would be 13%. How do you make 800 grams of a 12% by mass solution of Na2CO3? Well, you want 800 grams of the solution, and you know that 12% of it is Na2CO3. So when you are using a percentage, you usually multiply with the percentage, but of course you have to change it to a decimal. So we would need 96 grams of something, and if it's 12%, means it's 12% stuff. So that's the stuff, and then the rest, 704, is going to be water. Okay? Next, what is the molar mass of all this stuff? Or excuse me, what's the molarity of 200 grams of sodium hydroxide in 4,000 mils of water? Now you would need the molar mass. The first thing you need to do is write down molarity. Molarity is moles over liters. And you know that you're going to need molarity down here, so you really need to know that molarity means moles over liters. Now, you don't have the molarity here, but you have to determine what it is. So I need the moles of this stuff. So that means I'm going to need the molar mass. From the periodic table, sodium is 22.99, oxygen is 15.99, hydrogen is 1.008. That's going to be a 1, a 23, and a 16. You've got 1 sodium, 1 oxygen, 1 hydrogen. And we've sort of been doing it like this. Times 23 times 1. You don't have to set it up like this. This one's a pretty straightforward one here. So 23 and 16 is 39, and 1 is 40. So that is 40 grams, and I would write down that it always equals 1 mole. And so hopefully that tells you, okay, I have 200 grams. So how do I get the number of moles? Think about what you're doing. You divide the actual by the molar mass. So maybe memorize A over M, something like that, and you get 5 moles. So this is 5 moles. And then the liters, you of course, 200 grams is 4,000 milliliters of water. You move it 3 spots to the left, and that's going to be 4. And so 5 divided by 4 is 1.25 molarity. You could put 1.3 molarity, either one of these. Now here, you moved that 3 spots, okay? If I gave you grams of water, you'd still move it 3 spots, because grams of water and milliliters of water are the same thing. But don't start moving the decimal 3 spots every time you have some water. You didn't move it 3 spots here. You move it there because you have to change it to liters. This is 200 milliliters of water, but we're not doing a comparison of grams to liters. We're doing a comparison of grams to liters here. So be aware of that. Think. All right, so how do you make 500 milliliters of a 0.8 molar NH solution? So again, write down molarity. Moles over liters. But here you are given the molarity because it's a ratio. It's always some amount of moles to 1 liters. It's always 1 on the bottom. And so you need to recognize that I can set up a proportion to find the number of moles that I have. And of course, 0.5 times 0.8, you can enter it on the calculator if you want to. It would be a 40, and you would move it 2 spots, making it 0.4. But that's 0.4 moles of this stuff, NH3. So now you find the molar mass, which is 17 grams equals 1 mole. Hopefully this may help you realize that you can then somehow figure out how many grams you would need. You could actually set a proportion. Well, how many grams is this if 1 mole is 17 grams? But what you're really just doing is multiplying 17 times 0.4. And that's going to be an 8 and a 2 and a 6. So that is 6.8 grams in 0.5 liters of water. Practice as needed.